Right now, underneath some of the most beautiful scenery on Earth, thousands of workers are drilling, blasting, and boring through solid Alpine rock. They're operating in tunnels where temperatures can exceed 45 degrees Celsius, where the rock above their heads presses down with a weight of nearly 2 kilometers of mountain, and where a single miscalculation in geology could flood an entire worksite in minutes. Most people have no idea this is happening. Beneath the Alps, at least 6 to 8 major tunnel projects are under simultaneous construction, representing over $40 billion in combined spending. That's more than the GDP of over half the world's countries being poured into holes in mountains that most of us will never see until a train quietly glides through them a decade from now. We're talking about twin-bore tunnels stretching 57.5 kilometers under the French-Italian border. A controversial French-Italian link that has sparked protests, political standoffs, and 2 decades of cost escalations. A second bore through the Swiss Alps to double capacity on one of the world's most critical freight corridors, and several more besides. No single video has ever mapped this hidden underground network, until now. This is the secret $40 billion construction boom happening under the Alps, and it's actually far bigger than that number suggests. Okay, so why is Europe spending these almost incomprehensible sums of money to bore through mountains? The answer starts with a truck. Every year, more than 2.5 million trucks cross the Brenner Pass alone, one of the busiest Alpine routes. They rumble through narrow valleys, climb steep gradients, pump exhaust into pristine mountain air, and create bottlenecks that can stretch for dozens of kilometers. If you've ever driven through Austria or Switzerland during freight season, you know the pain. The existing rail connections aren't much better. Most Alpine rail routes date back to the 19th century. They were engineering marvels in their time, but they rely on steep gradients and tight curves that limit both speed and capacity. A freight train crossing the Brenner Pass today has to haul itself over gradients that slash its efficiency and restrict its load. The European Union looked at this problem and saw something bigger than traffic jams. They saw a continent that couldn't meet its climate targets, couldn't compete economically with integrated Asian supply chains, and couldn't keep choking its most sensitive ecosystems with diesel fumes. The solution? The Trans-European Transport Network, or TEN-T, a series of continent-spanning corridors designed to shift freight from road to rail and slash journey times between major European cities. And right at the heart of this network sits the Alpine mountain range, the single biggest physical barrier between northern and southern Europe. You can't go around the Alps, you have to go through them. The flagship of this entire underground campaign is the Brenner Base Tunnel, currently being bored beneath the Austria-Italy border between Innsbruck and Fortezza. When it opens, scheduled for 2032, it will become the world's longest underground railway connection at approximately 64 kilometers, surpassing Switzerland's Gotthard Base Tunnel. The numbers here are staggering. The total tunnel system, including the main bores, an exploratory tunnel running beneath them, and all the access shafts and logistics tunnels, amounts to roughly 230 kilometers of underground excavation. As of late 2025, over 200 kilometers of that, roughly 87%, had already been bored. That's the equivalent of tunneling from London to Manchester entirely underground. The tunnel consists of twin single-track tubes, each 8.1 meters wide, connected by cross passages every 333 meters. Operating speeds will hit 250 kilometers per hour for passenger trains and around 160 for freight. The journey between Innsbruck and Fortezza will drop from 80 minutes to just 25. But getting to this point has been anything but straightforward. Construction on exploratory tunnels began back in 2007, with main tunnel boring launching in 2011. That means by the time the first train rolls through, this project will have been in active construction for a quarter of a century. The engineering challenges are formidable. At its steepest point, there's up to 1,720 meters of mountain pressing down on the tunnel. That's overburden that would crush most conventional excavation methods. crews have had to navigate multiple geological fault zones where rock conditions change dramatically, sometimes within meters. To chew through this geology, engineers deployed an army of tunnel boring machines, each one a marvel of engineering in its own right. On the Italian side, a TBM named Flavia completed her drive to the Austrian border in May 2025, marking over 95% completion of mechanized tunneling on that side of the mountain. On the Austrian side, TBMs named Ida and Lilia completed significant drives through the Sill Gorge to Fawn section, each navigating roughly 8 kilometers of some of the most challenging geology on the entire project. And in the Fawn's Brenner section, a contract worth approximately 959 million euros was awarded in April 2023. TBM's Wilma and Olga began boring northward in September 2024. In September 2025, crews celebrated a symbolic milestone, the exploratory tunnel breakthrough connecting Austria and Italy. For the first time, you could theoretically walk underground from one country to the other through the new bore. One detail that often gets overlooked is the sheer scale of concrete segment production. At the Arental facility near the Austrian portal, workers produced over 59,000 precast concrete segments to line the Sill Gorge Fons lot alone. Manufacturing these on site, rather than trucking them in from distant factories, significantly reduced the environmental and logistical burden on the narrow Alpine valleys above. The total cost? Approximately 10.5 billion euros, funded by Italy, Austria, and the European Union. The EU alone has invested 2.3 billion euros through its Connecting Europe Facility program. This makes the Brenner Base Tunnel one of the most heavily EU-subsidized infrastructure projects in history. Now, if the Brenner is the flagship, the Lyon-Turin Base Tunnel is the firecracker. Officially known as the Mondamban Base Tunnel, this 57.5-kilometer bore beneath the French-Italian border has been generating headlines and heated protests for over 2 decades. The tunnel is being constructed by TELT, a binational consortium jointly managed by France and Italy. Main construction kicked off in 2019 with a target opening date around 2033. The original cost estimate back in 2002 was 12 billion euros. Today, closer to 30 billion euros when you factor in access routes and inflation, though the tunnel portion itself is estimated at roughly 8 billion euros in 2018 values. The French Court of Audit has repeatedly questioned these figures, suggesting the final bill could be even higher. And this is where Lyon-Turin gets messy. Environmental groups have opposed the project fiercely. Concerns include deforestation along access routes, disruption to mountain water tables, and the carbon cost of construction itself, which critics argue could take decades to offset through rail modal shift. Supporters counter that the existing Fréjus rail line dates to 1871, operates on punishing gradients, and is woefully inadequate for modern freight volumes. Without Lyon-Turin, they argue, trucks will continue to dominate this corridor indefinitely, and Europe's green transport ambitions will remain exactly that, ambitions. It's a genuine tension with no easy resolution, but construction has plowed on regardless. Switzerland, characteristically, is approaching the problem with methodical precision. The country already operates the Gotthard Base Tunnel, the world's longest rail tunnel at 57 kilometers, opened in 2016. Switzerland is also advancing a second tube for the Gotthard Road Tunnel, with construction underway and opening expected around 2030. Meanwhile, the Lurchburg Base Tunnel, a 34-kilometer bore that opened in 2007 at a cost of 4.3 billion Swiss francs, has a critical limitation. Only one of its 2 planned tubes was fully completed during initial construction. The other was only partially bored, meaning trains currently share a single full-bore tube through parts of the tunnel. In early 2024, Switzerland approved construction of the second Lurchburg bore at an estimated cost of 1.7 billion Swiss francs. This will effectively double rail capacity on one of the most critical north-south freight corridors in Europe, connecting the port of Rotterdam to northern Italy. When you pair that with the Gotthard investments, Switzerland is positioning itself as the backbone of transalpine rail freight for the next century. But the Alpine tunneling boom extends well beyond these headline projects. Austria alone has 2 additional major bores underway. The Brenner Base Tunnel, stretching 27.3 kilometers through the Eastern Alps south of Vienna, has been under construction since 2012. Originally budgeted at 3.1 billion euros, costs have swollen to approximately 4.2 billion euros. The tunnel is expected to open around 2030 and will slash journey times by roughly 30 minutes on the critical Vienna to Graz corridor, eliminating a steep 19th century mountain crossing that has constrained capacity for generations. Then there's the Koralm Tunnel, connecting Graz to Klagenfurt as part of a broader Austrian rail modernization. Together with the Semmering, it forms a contiguous high-performance rail corridor through Austria's Alpine interior, linking ultimately to the Brenner Base Tunnel and creating an unbroken sustainable freight route from the Baltic to the Mediterranean. This is what makes the Alpine tunneling program so remarkable. It's not a collection of isolated projects. It's a coordinated subterranean network being built simultaneously across 4 countries, designed to interlock into a single trans-European rail system. Now, this all sounds great, but the question that won't go away is, can Europe actually afford this? The combined spending across all these projects exceeds $40 billion, and that figure continues to climb. Cost overruns have plagued nearly every tunnel. The Semmering jumped by over €1 billion. Lyon-Turin's estimate has more than doubled since inception. Even the Brenner, considered one of the better managed projects, has required repeated budget revisions. And there's a glaring gap in the network that few people talk about. The Brenner Base Tunnel's northern access route through Bavaria, connecting the tunnel to the German rail network, is still in the planning phase. Cost estimates range between 9 and 15 billion euros, and political opposition in Germany is fierce. A Bundestag decision is expected in the first half of 2026, but there's a real possibility that Europe builds the world's longest railway tunnel only for trains to hit a bottleneck the moment they emerge on the German side. Critics argue the money would be better spent upgrading existing Alpine rail lines rather than boring entirely new tunnels. Supporters point out that no amount of upgrades can overcome 19th century gradients and curve radii. You need flat, straight tunnels to compete with road freight on speed and capacity. The environmental calculus is equally complex. Construction itself generates enormous carbon emissions. The concrete, the steel, the diesel-powered logistics. But over a 50-year operating life, the modal shift from truck to rail could reduce Alpine transport emissions by millions of tons. The question is whether the planet can wait that long for the payoff. Here's what strikes me most about all of this. Right now, beneath the most photographed mountain range in Europe, an invisible continent is taking shape. Hundreds of kilometers of tunnel, bored through ancient rock by machines with names like Flavia and Ida and Wilma, connected by thousands of cross passages, lined by tens of thousands of concrete segments, and funded by billions in public money from a dozen different sources. Most Europeans have no idea it's happening. More than 15 years after construction first began on the Brenner Base Tunnel, and more than 20 years after Lyon-Turin was first proposed, these projects are finally approaching a tipping point. Breakthroughs are accelerating. TBMs are meeting in the middle of mountains. Concrete is being poured for operational infrastructure, not just exploratory bores. The Alpine tunneling boom represents something profound about Europe's bet on its own future, a belief that rail, not roads, will define continental connectivity for the next century. That spending $40 billion underground today will pay dividends for generations. That the climate crisis demands infrastructure on a scale the continent hasn't attempted since the post-war reconstruction. Whether that bet pays off depends on political will, engineering precision, and the patience of taxpayers across half a dozen nations. But the machines keep boring. The segments keep stacking. And deep beneath the Alps, the future of European transport is being built in darkness, 1 meter of mountain at a time. Thanks for watching Hard Hat Industries. your source for the massive engineering and heavy iron shaping our world. If you appreciate the scale and technical complexity of these builds, hit like, subscribe, and turn on notifications so you never miss a breakthrough.